Told you. Videos all week, so we're ready to go for some more videos. Getting ready for a little math action. But before we get started, of course, you know some of the teacher at the universe, the Algebra 1 champ, the middle school math champ. Gotta do a little bit of fun stuff first. So, open up some things first. Found some hockey mates. The hope is here, of course, we get some Lightning players because they're the only team that matters. Let's see. The Canes, that's okay. You can hang out, I guess. We'll let you hang behind QB back there. And a Boston, the Bruins. You can't hang out. I don't think so. Sorry. All right, again, some baseball players. You got some lockers. You got, you've got a full out locker ready to go with the Gatorade bottle, Gatorade jug sitting up here. Let's see what we got. Again, beginning Astros players, of course, just like the Bruins guys, we throw them away. Oh no, we're good. We're set. We got Kikuchi, sure. Mariner pitcher, I do know that part. Kettle Marte, Miggy Cabrera. I mean, some good players there, and of course, no Astros. Even better. It would be better if it had been a Rays player or a Braves player, but I mean, I guess beggars can't be choosers. They can sit up there. Oh, you can go away. Oh, we got one more thing. Harry Potter bag. See, last time we did a Harry Potter thing, I didn't know what it was. Dane, again, thank you for helping me out with the mermaid being from the fourth movie. Yeah, that's right. So let's see. This is an easier one. See, we only can get like Harry Potter or the main characters, which means, oh no, it is. Oh, sweet. Look at that. Harry Potter running around, ready to go with a wand in hand. You can hang out with Jorge Alfaro out here. Sweet. How you did that? Oh, got some Disney pins for today, of course. We got Mickey inside of a Mickey hand. 4 fingers, of course, because it's easier to draw than 5. Looks like Anna riding around a Skyliner, which means she's probably getting stuck, because that's what happens with the Skyliner. And a Jiminy Cricket Mobile. Sure, why not? Some good Disney pins for today. And of course, time for quotes. Throwback quote. Mirrors can't talk back, or can't talk. Luckily for you, they can't laugh either. See, that's funny, because it's mean. All right, and today's quote of the day. Life is not a fairy tale. If you lose your shoe at midnight, you're drunk. Well, hopefully none of you are. Obviously, you're middle schoolers. Clearly not doing that. But if somebody you know, an older cousin, college age, 21 and up, of course, loses their shoe, bad things could happen. You don't want to try and be Cinderella. All right. So we're going to let this hang up here, of course. Oh, what have we done? Well, of course, you know what time it is. It's time to do a little math. Let's go to the board. All right, now, Happy, Chubbs, Otto, pay attention. This is going to be on the quiz. Pre-Algebra guys, ready to go? Today, yesterday we talked about irrational numbers. We talked about being able to estimate them, but I remember we probably should talk about what irrational and rational numbers are as well. So today we're going to talk about classifying numbers. Taking a number, looking at it, be able to label it with some different ways of describing them. Now, all the numbers we deal with are real numbers, which helps. Because not real numbers would be ridiculous. And we don't have to worry about that until like Algebra 2, so you're good for a while. We have real numbers. We have 2 types of real numbers that we deal with. We've got rational numbers and irrational numbers. Now remember, rational numbers are just another way of describing numbers that can be written as a ratio to integers. So things like 27 over 4. That is a rational number. 4.5. Rational number. Negative 0.3 repeating. Again, rational number. Irrational numbers are then numbers that cannot be written as a ratio of 2 integers. So numbers like the square root of 29, the negative square root of 3, pi, all examples of irrational numbers. Now, if a number's irrational, that's the only way we describe it. We're done. But if it's rational, there actually is another subset we could use, or another subset of rational numbers. To describe them, we have what are called integers. Integers are rational numbers that are also able to be written as positive or negative whole numbers. So things like -16, -2, -3 will be integers. Now, there also are positive integers. We have another word we can use, another name we use to describe those. We call them whole numbers. Numbers like 2, square root of 4 is 2. 100, 0, all will be whole numbers, okay? So this is just a way we can describe and represent our different numbers. And we're going to do some examples. We're actually going to work through a couple in just a second. And then we'll be done for today. Pretty short lesson, thankfully, but we'll be right back with the rest of it. As always, special shout out to these guys right here, coming in every day, learning a little math with you and with me, the siblings, Anthony, Ross, Rebecca, and Nelson. Oh, so happy to see y'all again. As always, hope you enjoyed the math. So we'll leave our chart up here to help us. We're going to label and classify these following numbers: square root of 5, -17.84, and 18/6. So start with the square root of 5. Is it a real number? Yes. Remember, we're only dealing with real numbers, so we're going to start with that. Now the question we come to next, going from real, is it rational or is it irrational? The square root of 5, can that be written as the ratio of two integers? Well, since we see a radical, one thing we can think of is 5 a perfect square? If it is, then it'll be a rational number. If it's not, then it's irrational. So is 5 a perfect square? Simba, what do you think? Of course not. 5 is not a perfect square, so we have an irrational number. And since it's irrational, that's the end of our labeling. Square root of 5 is a real number and is also irrational. Our next number, -17.84. Well, again, we know it's real. All the numbers we're dealing with so far are real numbers. Is it rational or irrational? Well, -17.84, it's written in a way that, just like some of these numbers over here that are rational. So it's got to be a rational number. Is it an integer? So we go from rational, is it an integer? Well, no, it's not, because we have a decimal point. Since we see that decimal, we know it's not going to be an integer or a whole number, so that's it. Real and rational. Our last one, 18/6. Again, we know it's real. And I see as a ratio, I already see the ratio. I see it written as a fraction. We know it's going to be a rational number. Now I would be tempted to stop. Do we see the fraction? We're good to go, right? Fractions aren't integers or whole numbers unless, can 18/6 be reduced? Can we simplify that? Of course we can. 18/6 is the same as 3, which means it's also an integer and a whole number. Pretty simple stuff, right? Just being able to classify, recognize what numbers we're looking at, and ways to describe them can help us in understanding the numbers a little bit better. That's our lesson for today. We'll be right back to close it out, and then we'll be back for tomorrow.
6.5 hours later.
Okay, brief lesson today, but it's a good one that's going to help us going forward. Make sure, again, if you're needing extra help on Edgenuity, if you're needing an extra retake on a quiz, make sure you send me a copy of your notes and you tell me what section it is that you're wanting to do a review on. I'm happy to help you out, but I can't unless I know. I can't read your heads. So again, if you're needing a little extra help, make sure you're contacting me. Other than that, we're going to break for today. We'll be back tomorrow with another video. So till then, we're out.